To find the value of the limit, we begin by thinking about what happens to our function as x approaches infinity. So as x is getting larger and larger and larger in the positive direction, that fraction 1 over infinity gets closer to 0, and our exponent remains infinity, which leaves us with 1 raised to the infinity, which is an indeterminate form, but not an indeterminate form that we can use L'Hopital's rule on. We want 0 over 0 or infinity over infinity. So we have to use a couple tricks of algebra to get this into the right form. First, we're going to define our function and then take the natural log of both sides. This is going to allow us to use the exponent rule for logs to take the x that's in the exponent and bring it out in front of our natural log, which will give us x times the natural log of 1 plus 1 over x. We can then rewrite this as a fraction, changing the x that's being multiplied into dividing by 1 over x. And now, if we substitute in infinity for x, we're going to end up with the form 0 over 0, which means we can apply L'Hopital's rule to this new function. And the key here is we're taking the limit and finding the limit of the natural log of x, so we're going to have to take our answer when we're done and go through one more set of steps to actually find the limit of y, which is the function we're originally looking for. So we apply L'Hopital's rule, we take the derivative of the numerator and place it over the derivative of the denominator, and that's going to give us, in our numerator, 1 over 1 plus 1 over x, and that's going to be multiplied by negative 1 over x squared, and that's all going to be over negative 1 over x squared. So we can cancel out the negative 1 over x squared in the numerator and in the denominator, and that will leave us with the limit as x approaches infinity of 1 over 1 plus 1 over x. Now if we think about what happens to this function as x gets closer and closer to infinity, we can see that the denominator, the 1 over an x approaching infinity, is going to get closer and closer to 0, which is going to leave us with 1 over 1 plus 0, or 1 over 1, or 1. Now, we have to be careful. What we've solved for here is the limit of the natural log of y. We found that that equals 1. To find the limit of y, we need to take the inverse and get rid of that natural log. So we're going to take the limit as x approaches infinity of e raised to the natural log of y, and then we have to do the same thing to the other side of the equation, so that will be e raised to the 1. And that will leave us with our final answer, which is that the limit as x approaches infinity of y, the function we're looking for, is equal to e to the 1, or just e.